MAP4C 3.0 two-variable data intro. In this chapter, what we're going to do is investigate the different visual representations of data with both one and two variable data. Our first introduction, we will begin to interpret various types of graphs, as well as graph and model linear relations, because that will help us in the future when we're looking at correlation between two variables. So for our first example, data can be represented in a variety of ways. Graphical representations can include bar graphs, histograms, scatter plots, and circle graphs, and we'll get into each in future lessons. What do the red bars in this graph represent? The blue bars. So, looking at the red and blue bars, what do each represent? So take a moment. Hopefully you noticed the legend above that the red represents the tuition during the years 2007 to 2008, and the blue bars represent 2008 to 2009, the tuition rates. So, for which program did the tuition change the most? Looking at our graph, what we would need to investigate is a comparison between the two bars. This is a double bar graph where each bar that is adjacent represents a different year. So, the largest increase in this graph would be for television and film. I see the largest difference in height between the two bars representing the largest tuition increase in this program. C. Estimate the tuition for photography in 2007 and 2008. This is a very precise, challenging to zoom in on answer, but we can see that this blue bar and red bar for photography are approximately at this point on the graph, and between 4,000 and 8,000, that midpoint is 6,000. So it's very tough to be exact, but we would say that the photography in 2008-2009, the blue bar is approximately 6,000, maybe 10. It's in the red at about 6,000. There's not really a great discrepancy between these two, and it's also very challenging to get very precise for these examples when there aren't also grid lines going across. So it's an approximation, but sometimes the details in graphs, as far as the exact dollar value, can be sacrificed in order to give a better overall representation. So that would be definitely one of those examples. So try these problems on your own in order to challenge your understanding of different graphs. I see a histogram, circle graph, and a scatter plot. We'll investigate each of these, a table, and we'll investigate each of these further in future lessons. But let's talk about an important concept that we learned earlier. Working with slope and line graphs. Slope is a measure of the steepness of a line. A positive slope means the graph goes up and to the right, so this is a negative slope because it goes down to the right. But as you go from the left to the right, if it goes up or increases, then it's a positive slope. And this is a visual of a negative slope. So, a linear equation. In general, the line, it can be described by two factors: the slope, the angle at which it's inclined, as well as the y-intercept, b, where it crosses the y-axis. So, that being said, this equation is just a relationship between x and y that will allow you to understand the characteristics of that line. The slope, denoted by m, can have multiple representations. In general, it is rise over run. So, for this example, we can see the actual values on the graph. And when that is possible, we can use this definition of rise over run because we can count. Rise, it goes down 2 units between these two red points. So a rise of -2, and a run, so how far does it travel to the right? 1, 2, 3 units. So we would say that our rise over run is -2 over 3, as you see here. A more general point slope calculation for the slope is y2 minus y1, and all that that means is that this point is x1, y1, and those are subscripts representing the name of this point. And this is x2, y2. So the point on the left is x1, y1. The point on the right is x2, y2. And what that will give us is a calculation 2 minus 4, because the y2 minus y1, y from the first, is 4. And since each point is an ordered pair, x and y, we're using the second number in each case. Then x2 minus x1, so the x of the second point, 9, minus x of the first point, 6. 9 minus 6 is 3. So both accomplish the same goal, but are used in a different context. This is a little bit more powerful for word problems and whenever you can't visually see points on the graph, whenever it's not very clear where they're located. If you can identify specific points where it's clearly going through grid lines, you will get the same slope whether we pick this point and this point. Always will end up with the same slope if it's a line. Next, the y-intercept can be seen with visual inspection. It crosses the y-axis at the point where y is equal to +8. So b is equal to 8, and therefore if we have m is equal to -2/3, b is equal to 8, we can combine that to express this line using the following equation. Y is equal to -2/3 x plus 8. Try the following questions in order to be able to calculate the line of best fit for these points